Two Parkinson a Pod is powered by Parkinson's UK, the charity that's here to support every Parkinson's journey every step of the way. Wherever you're from, whatever you need, visit parkinsons.org.uk for more information. We're back and back with a bang. Hello, welcome to Two Parkinson a Pod, the podcast for people with Parkinson's, by people with Parkinson's. I'm Dave, he's Kuhn. Together we've had the dreaded lurgy for ages and ages and ages and ages and ages, 26 years.
Ages and ages and ages. Just trying to get comfy in my booster cushion here, Dave.
Yeah.
I can't quite reach the mic, so Dave gives me a couple of cushions.
I'm just going to give you a bit of geography of where we record this, because we do it from my kitchen. Kuhn's got a strategically placed food mixer above his shoulder.
Oh, right.
A basket of eggs. And some baskets with a load of my knickers in it.
Your knickers?
Yeah, dirty washing basket behind you.
You're talking about your knickers?
Yeah.
Nobody wants to see or even hear about your knickers, thank you very much. That's behind me, is it?
Yeah,
it's a good job I've got a really stiff neck at the moment, because I can't bend round to have a look.
Speaking of fashion, I've been cutting edge of fashion this week. I've got some new trainers.
Cutting edge is a bit of a stretch, Dave.
Nike have launched this thing called Easy. I'm not sponsored by Nike or anything, but they've
Should
launched
be.
it, which, yeah, great idea, yeah. Easy Ons they're called, and they're really cheap.
Yeah.
50 odd quid for a pair. They've got a stiff...
50? I thought it was 60 or 70.
No, I think £56 you can get one
Oh,
for.
right.
We'll put the link on the show notes, but they're dead easy to get on and off. They've got a stiff back. Like me, right? Really. And
What do you call that? The thing at the back?
Heel.
So whereas most heels kind of tend to fold
Squash
down,
down
when you're trying to put your heel in, this one just is firm, right?
Yeah, and they've got Velcro as well to fasten them at the front. Just pull it down, it tightens your trainers, and you can fasten the front with Velcro. Perfect.
Dave's doing all kinds of hand actions demonstrating this, but there is actually a video that I took of you the other day.
Yeah, putting my shoes on.
You're putting your shoes on, which this all sounds a bit silly if you're not a parkie, but putting your shoes on is one of the more complex challenges that we face, and witnessing you put those on, it really is easy on,
yeah,
right?
really good. I'm really impressed with them. It's good that Nike are doing something which they may not have done it deliberately for people with Parkinson's, although they might have done.
Or people with
disabilities of any kind, yeah.
yes.
But it's worked out brilliantly, and I've noticed they're going to do a range of clothing with Velcro as well, so that should be quite interesting.
Oh, right,
yeah.
like our suggestion from our listener,
yeah.
I think it was John from Scotland.
Yeah, we're going to start
Custom
a
made
revolution.
Yeah, Velcro's the way to go.
It got me thinking about my feet as well, because I went for a pedicure the other day.
Oh, right.
Not something I normally do, but I'm really struggling.
You do like your odd pedicure. You do.
I like a haircut and a pedicure, yeah.
Yes.
It's fantastic. I went to the little Julie's Nails down the road.
Julie's Nails.
Yeah,
Oh, good old Julie.
You sit down.
I don't know Julie.
You sit down, they've got a massage chair for you, which is
Oh,
gorgeous.
right. What, like one of those automated machine?
Yeah. It's great.
Yeah.
You just sit there getting a massage.
Yeah.
And for some reason, your toenails get really thick. I don't know if it's Parkinson's or something, but
Yeah.
your toenails really get thick when you get older.
There's a very limited time where I can cut my toenail
After
with...
a bath or something like that.
Yeah, but also my hands have got to be working. I've got to be dyskinesia free, I've got less rigid. Probably first thing in the morning is the only time I can cut my toenail. And of course, you've got to bend down. It's a whole process, isn't it?
Come with me to Julie's Nails. Perfect.
I was wondering what you're going to say there.
It's great because they take the rough skin off your feet as well. With Parkinson's, you've got to look after your feet because it's easy to ignore them. You just carry on life and don't bend down. And your toenails get long, your shoes get uncomfortable.
Yeah.
And it just makes a hard life even harder. So
Yeah, I was talking to Julie Jones, a physiotherapist, who had a patient that was complaining about his feet, and actually turned out he had an ingrowing toenail. I don't know if that was Parkinson's related or not, but foot care is a thing. Same with dental care and eye care. It's easy to neglect these things, particularly when you become less able, shall we say, and these things become more challenging.
So come with me, Team Parkies. Let's go down Julie's Nails together.
Yay! How much is it?
25 quid.
That's not bad.
In London, it's pretty good, isn't it?
Yeah, that's not bad. Worth doing.
I'm going to ask you the question that everyone's been everywhere you go with you now. People go, "What's the news with your DBS, Kuhn? What's happening with your DBS?"
Well, yeah, it's nice and not nice. People ask me. No, it is nice, and thanks for everybody that's reaching out and everybody that's been through DBS, offering to share their experience. You know, people like Ellie, Paul, Scott, another Dave, reaching out and sharing. Really very kind and very informative. But yeah, when people ask me how do I feel, I'm not sure what I should say. Should I say I'm scared? Should I say I'm looking forward to it? I don't know.
Absolutely bricking it, yeah.
To be honest, not yet. Although I did have an appointment with the professor at Queen Square earlier this week, and I've been told it's May now.
Right.
So I'm at the mercy of the NHS, but the current target is May, and I don't think it will become real until I go into hospital with what would be the day before. and I can picture myself putting on a gown. And I think the moment it would become really real for me is when they put me under, and I've got to, or before that rather, when I have to say bye to Helen, and because that will be some time before I'm actually put under.
How long is the operation going to take?
Get this, he said 2 hours.
Really?
Yeah, well, the actual operation bit of it, 2 hours. Isn't that remarkable?
Well, you've probably got an empty head. They don't have to avoid too much brain.
It's certainly a small head, small brain. There's a whole, I don't know if you know about the process, but effectively you go for a couple of MRIs. One of the MRIs involves you having a frame attached to your head, this Hannibal Lecter type frame attached to your head, so you
can't move. Yeah,
your brain itself can't move. It's screwed into your skull, and that bit I may or may not be awake for. And then having an MRI with that on, and then you're wheeled down to the operating room, and that bit takes 2 hours. And hopefully this will all be in the morning, and then I'll be awake in the afternoon on the ward.
I said when you wake up, Helen will be holding one hand, I'll be at the other side holding the other hand.
Yeah, I'm not sure if that's a good thing or not. I'm not sure that's a good thought or not. But it is a reflection of the warm wishes I've heard from people, and it's really quite nice. But ask me again when I've got an actual date and I'm going in, or the night before, and I think I might be a little bit more nervous, shall we say.
I've had an interesting voice message from Charlie Appleyard from Sport Parkinson.
Oh, yes.
He said, any chance that Kuhn could come and ride every roller coaster in Britain with me? Because you're not allowed to ride a roller coaster when you've had DBS, apparently. So he wants to go to Blackpool and all around Britain riding roller coasters.
Yeah, to which my answer was...
I'm absolutely crap scared of them.
Yes, I think I'm probably more scared of that than the DBS. Yeah. I've never been... Sorry, Charlie, I've never been into roller coasters at all. A, I'm scared of them, and B, I'm not the sort of person that gets that adrenaline rush of things like that. My rush comes from things like this, doing the podcast, and I'm not. I don't get a thrill out of the scary things.
You're telling me DBS you can't have a sauna either.
You can't have you can't be in a sauna, steam room. There's restrictions on having an MRI. You can't go near magnets. Apparently, you can't go over an electric hob. I'm sure
you can start frying.
Yeah, which is a good excuse to
not do any cooking.
Yes, exactly. I'm sure there's a few other restrictions as well that I'm coming across, but all relatively minor things in the scheme of things. I can still do in everyday life. And they asked me this week, what's your actual motivation for having DBS? And I said, well, I want to beat Dave at tennis. That's one of my motivations. But it's the things like putting my shoes on. And I went to the dentist recently, and I was wriggling around so much for some gum treatment, and she had to stop. I think I might have told this story in the podcast before. She said, for your safety and my safety, I have to stop. And it just got me thinking, like things like that, putting on my contact lenses, the day-to-day challenges, which are just minor things in the scheme of things, but minor things that can become problematic if you neglect them. And it's those are the things that are driving me towards having DBS. And it's the right time, and I should say I'm in great hands with the NHS and all of this UCL, Queen Square, the National Neurology Hospital, and the dozen or so centres around the UK do a great job. And I'm sure I'm going to be saying this more than once on this podcast in the next few months, but the NHS, the fact that we can have all this treatment for free, unlike most places in the world. I know this country is suffering a lot in many ways, but for that I'm very grateful, right? Because all in all, if you did this privately, it'd be something like an £80,000 operation.
Really?
Yeah, it's very, very expensive. People in the States, I think it's covered generally by their insurance, but the NHS is very unique in that way, right? There's not many countries in the world, and also there are many countries where just DBS is just not available at all. So I'm very fortunate, and
many countries where levodopa is not available.
Yeah,
so.
Exactly. Yeah. So I'm very, very fortunate, and not sure how I feel about it.
You're not getting normal DBS. Typically, you're getting all singing, all dancing one with loads of wires and 2 battery packs a lot. Techie Kuhn.
Yeah. So the convention in the UK is to have 2 electrodes placed targeting the SDN part of your brain. I'll be having
what's SDN?
thalamic nucleus.
Oh, very good, yeah.
Nervous when you asked me.
I'll have 2.
Whereas I'd be having that and 2 more electrodes for the GPI target, which is the target that addresses dyskinesia and dystonia.
Right. Do you know what GPI stands for?
Palamus or something. I don't know. I'll leave some links in the show notes.
Sorry, yeah.
But 4 electrodes instead of 2. Which is a convention, I think, in North America, but less so in Europe and certainly less so in the UK. They've done 7 cases of it in Queen's Square, so it's
cutting edge.
Cutting, literally, or drilling edge. It's relatively new, and the other part that you're alluding to is I'll be having at some point to the assisted DBS, which is the smart DBS, which is sensing your brain and reacting and delivering a level of stimulation according to what your brain is doing at any one time, rather than being permanently on, which is the normal type of DBS.
It's quite interesting because when this was shown on the BBC, they wrote an article about it, and everyone was texting me again, found a cure for Parkinson's, found a cure. Amazing, this guy feels like he's been cured.
Yeah.
And it was a false dawn, really, wasn't it? It's old technology, but just souped up a bit. GTI model.
Yeah, exactly. So it's the same hardware.
Yeah.
So it's all done by software. And all the smart stuff with DBS, it's not the operation itself. Well, obviously there is about placement of the electrodes and things, but actually all the tweaking of the settings, which happens in several sessions months after the operation itself, is where they fine-tune you. That's where if your speech perhaps is impacted, they'll tweak a setting to try and address that. Yeah. Where your mobility or your mood is impacted, they can tweak a lot of those things after the fact, as it were. So if you are thinking about DBS now or in the future, just be assured that actually it's a very intelligent system. It is very high tech, and it's not a one-hit wonder. It's not just the operation. It's actually the things that they can do afterwards via the software and via the programming. That's where the magic happens. I'm
hoping I can get a little copy of the software so I can turn you off now and again.
Yeah. Well, I think the controller I'm going to get is an app that sits on the phone.
Great.
So anyway, it is what it is. And it feels like my time, and I'm in good hands and the right treatment for me. It's not for everybody, as we keep saying. But one piece of advice that I'd give anybody, even if you're half thinking about it, even if you're really nervous about it, but you think it might be in the offering, get yourself on the list. Yeah. Get yourself on the list, because in the UK there's a long waiting list. I've been on this journey for a year now. There's people in Scotland that are waiting for 5 years. Mm-hmm. So just get yourself on the list.
You can always not go through it.
You can always not go through it. You can back out at the end. And one thing that this has reminded me of going through this process is Parkinson's doesn't stay still. It progresses, unfortunately. And even in this short space of time when I've been on this DBS journey, I can feel my progression. I can feel my dyskinesia coming back with a vengeance after I had a period of where it was plateaued. My tremor, slowness, stiffness is all worse.
You said you've been biting your lip as well.
I've been biting my lip. Yeah, you do this as well, don't you?
Yeah. It's one of the untold stories of Parkinson's, isn't it? People at night, you sort of chew the side of your mouth.
Is it at night? I feel it in the morning. Yeah. If I just show you, it looks a lot of gross. But
look like you've been round with Mike Tyson. You got a thick lip,
yeah. Cheek, tongue, under the lip. And I keep biting in the same place as well. It's normally when I'm having food.
It's because it's already sticking out, and
that's what I had to say.
You just bite it.
It's so painful, Dave.
Really horrible.
Really.
I've got a couple. I've got one on the side of my cheek, one just under my lip, left hand side.
Yeah. Oh right.
Same as you. Crazy.
What else are we talking about today?
This one's called Stemming Parkinson's. It's quite interesting because...
and the clue's in the title, isn't it?
Yeah, we're heading to Scotland, the Centre for Regenerative Medicine at the University of Edinburgh. Professor Tilo Kunath is our guest, one of the world's leading experts in stem cell research. The hope is that implanted cells will one day reverse Parkinson's. How close are we? No, let's find out.
Let's find out.
Professor Tilo Kunath, welcome to Two Parks in a Pod.
Thank you. Good to see you guys.
Just give us your backstory, because you're based at the Centre for Regenerative Medicine at the University of Edinburgh. That's not an Edinburgh accent, is it? Must be. Tell us your backstory.
You're absolutely correct. Yeah. So I'm Canadian by citizenship, and I grew up in Toronto. I did my PhD in developmental biology. So this is quite different than most people who work on Parkinson's. So my background is understanding how embryos develop, essentially from when sperm fertilizes the egg. I was learning how embryos developed, and then I moved to Scotland, Edinburgh, Scotland, where I am now, in 2003. and I worked with a very famous stem cell researcher. So in the late 90s, we were getting all excited about stem cells, and one of the biggest researchers in the world was in Edinburgh. His name was Austin Smith. He's now moved to Exeter, but I came here as a stem cell researcher. And through serendipity, through funding, through some good coincidences, I became a Parkinson's researcher probably in 2007, 2008. And then I've applied my expertise and knowledge in embryo development and stem cell technology to address problems in Parkinson's.
And just going back to those early days, so going back 20, 30 years, is this the time and the centre that came out with Dolly the sheep?
Yeah, so Dolly the sheep was happening sort of in a parallel way. So Sir Ian Wilmot cloned Dolly the sheep and became world famous at Roslin. And that was before I moved to Scotland. So he did set up the centre I'm in now, which is the Centre for Regenerative Medicine, after the cloning of Dolly the sheep. But Edinburgh was famous for Dolly the sheep as well. It's not the reason I came here, but sort of the two sort of areas of research came together in a few years after arriving.
And there was a cruel twist of...
I was going to say, Sir Ian Wilmot actually got Parkinson's, didn't he?
He did, yeah. So his office was a few offices from mine, and he actually hired me. So he to become a lab head. So I was just what's called a postdoc when I arrived. So he did get Parkinson's, and I met a lot with him when he was progressing with Parkinson's during the pandemic. And he, of course, supported all the research going on in Edinburgh and in Scotland and worldwide with Parkinson's. But you're absolutely correct. He did have Parkinson's.
Can I go back a few more years? I read this story about your childhood, and there's a particular story about cockroaches. Would you mind sharing that story?
How did you find that?
I was quite amused by that. We do our research on this podcast.
That's really old. Yeah, that's primary school. Yeah, me and a friend, we read somewhere that you could cryopreserve cockroaches and they would come back. And sure enough,
freeze them, basically.
Yeah, you could freeze them without any special. We freeze a lot of cells. We can talk about freezing cells later on in the podcast. But yeah, this was a science fair. I'd have been 8 or something. How did you find that? It's amazing. And I have to admit, we tried it. We heard also goldfish you could do. So we tried that next year, and that didn't work. But cockroaches, they will survive anything. An atomic Armageddon, an ice age. Yeah, they do come back. Yeah. So this was our first foray into science. Interesting.
So, needless to say, your inquisitive nature and your interest in biology and biochemistry started at a very early age.
Absolutely, yeah.
Where are we at in terms of your research at the moment, and how far down the line are you?
So we work on stem cell models of Parkinson's, and we make neurons from these stem cells. So most of my lab works on disease modeling, meaning we try to recreate Parkinson's in a dish, and then we test drugs on them. So
could you inject Parkinson's into a mouse then? Is that the sort of thing we're talking about here?
So the stem cells are also used to inject into mice, but not to give them Parkinson's. They're being used to repair Parkinson's. Stem cells themselves are not. They don't have Parkinson's, or they don't make dopamine. But we need to turn them into the neurons that can have Parkinson's, or that can make dopamine, such as a healthy dopaminergic neuron, which are the neurons that are lost in Parkinson's. So 2 things we can do with these neurons. We can try to model Parkinson's in a dish, which is what we do a lot of in my lab, or you can use those neurons that you make for a transplantation. So this is what's being done by a number of clinical trials, not by me, but we do similar experiments with rodents. But I can talk about these trials that are ongoing, which are really based on stem cell technology, which inject new neurons into the brain of people with Parkinson's. So this could be transformational. For me, this is the only treatment that can reverse some symptoms of Parkinson's, not all. It's not a cure, but it can rebuild the lost dopaminergic neurons in Parkinson's by simply replacing them. The acronym that is used is CRT, and that stands for cell replacement therapy, because the neurons are essentially being replaced.
So I'm just going to play that back just to make sure I've got my understanding.
Sure.
So Dave and I, in our second decade with Parkinson's, and we've been taking levodopa for pretty much all that time. And what levodopa is doing is effectively trying to replace the dopamine itself that we've lost already. But what you're talking about, stem cell, is actually replacing the neurons that produce the dopamine itself. Is that right?
Exactly.
So you're trying to fix the problem rather than fix. I'm trying to think of an analogy here. What is the right analogy?
Yeah, I was trying to think of a car analogy. It's replacing a part that you have less of. So say you've got a certain percentage of neurons left, but you want it back up to 60 or 70%. So you
Right.
top up the amount of neurons that are physically inside the brain with more new neurons. So it's a replacement of a part, essentially, you could think of it. But again, I say it's not a cure because Parkinson's is very complicated, right? There's all sorts
Yeah.
of other issues that are not related to dopaminergic neurons. So even on your podcast as well, I hear about constipation, loss of smell. All these things are not related to those specific neurons.
Cognition.
Yeah, cognition as well. So the motor symptoms are related to the loss of dopaminergic neurons. So the replacement of these neurons should do two things: reduce the reliance on levodopa, but also address the symptoms related to the motor symptoms. So these two things are what's anticipated for a cell replacement therapy to be successful. It will not address issues such as dementia, so Lewy body dementia, peripheral issues such as the skin problems or the gut problems or the cardiac problems there's sometimes in Parkinson's. On paper, it shouldn't address these specifically, but the motor symptoms it should address very directly.
Some people have already had stem cells put in the brains. What's happened to them so far?
Yeah. So there's a couple trials going on, and they've only started in the middle of the pandemic or after. So there's three major ones, one in Japan, led through Kyoto, one led out of New York by Blue Rock Therapeutics, and then the UK-Sweden trial is being run mostly out of Lund, but a lot of support from Cambridge. And they have not published a paper yet on the results, but you can gather some of the information from meetings. So I go to conferences and you can hear some of the progress that is being made. So the Blue Rock trial is looking really interesting and exciting, and they're releasing some of their information in press releases. And they're gearing up for what's called a phase 3 clinical trial. And they're gearing up for that because they're seeing some really positive signs in their phase 2 clinical trial.
And phase 3 is when it gets exciting, right? Phase 3 is when we're getting to scale.
Yeah, so phase 1 and 2, things can fall down if things are not working. So what they're seeing in the Blue Rock trial and that they've reported is that they are seeing increases in dopamine production in the brain of people that had these transplants. So they can use imaging to look at dopamine production, and they are seeing, on average, increases in dopamine production. But one of the sort of drawbacks of this therapy is that it takes probably 1 to 2 years before you know if it's working, because what gets transplanted are very immature neurons, and then they need to mature inside the brain. And this maturation process is a sort of a replaying of embryonic development, which is why I'm very familiar with it, because my background, as I mentioned, from Toronto is embryology. So these neurons are very immature when they're transplanted, and they have to mature in the brain and then start making dopamine. So they don't make dopamine when they're transplanted, but they might take 6 months before they start making a little bit of dopamine. And then they mature more and they mature more. And they're essentially replaying embryonic development, but in an adult brain. So it's a huge ask of these cells to do this. But it's amazing that it has been working in mice and in rats and in monkeys for the last 10 years. It's been working in these animal models. And it's fantastic to see that they are finally human trials for this type of therapy. But it's not like deep brain stimulation, where if deep brain stimulation works, you know fairly soon if it's working. You know within weeks if it's working. Stem cell therapy
to grow effectively. It has to grow.
Stem cell therapy needs the neurons to grow. It needs to innervate the striatal cells, which is where the dopamine is needed. It needs to release dopamine in a normal fashion, and it takes 1 to 2 years before you can see, is it working, is it not? Patience is needed, and this is why any sort of success, we need to be patient. Even though the trial started in 2021-ish, we need to keep an eye on it, and we need to have no major sort of safety issues, and then we'll see. So this is really a good time to be keeping a close eye on what's happening.
You mentioned the logistics of getting the stem cells in the brain. How does that work? Do you need a major operation to get them in?
You do. It's less major than a deep brain stimulation. So deep brain stimulation is a major neurosurgical operation. So So
It's still brain surgery, though, right?
it is still brain surgery, absolutely.
Yeah.
So logistics are this. So the stem cells, you have to start them on a path of making dopaminergic neurons in the lab. So you start them on the way, part way. You freeze them when they're immature in the lab. So all this is done in the lab. And then you do all sorts of quality control to make sure that your cells are good and that there are no longer any stem cells remaining in your vial. So these are the word that we use are progenitor cells. They're dopamine progenitor cells. And then you go to the neurosurgeon. And then you say, I've got these dopamine progenitor cells in a vial. They're frozen. Do you have the right patients that are suitable, that meet all the criteria that we can transplant these progenitor cells into? And then it is a surgery. It is a neurosurgery, a stereotactic setup, but it's a very precise, it's very controlled. There's no hardware left in, so there's no electrodes as there are with deep brain stimulation. So then they go in with very thin, long needles and deposit these cells in the brain on the left and the right side of the brain of the Parkinson's patient. And then they come out with the needles and then recovery phase. And then they wait. You have to wait for these cells to mature. So the other thing we didn't speak about is that the cells are, of course, not from the person. So there is immunosuppression required. As you would transplant an organ, you get an organ donation, you need immunosuppression. So you do need immunosuppression, but they only need it for about 1 year. You don't need it for a lifetime.
So where are they coming from, and what are the ethics around this?
Yeah. So where do they come from? Yeah. So the stem cells come from two general places. So one of them is from what's called an embryonic stem cell line. So this is the New York Blue Rock trial and the UK Sweden trial are using this type of cell. So this type of cell comes from in vitro fertilization clinic donation. There's an embryo called a blastocyst that's donated. It's turned into an embryonic stem cell line, and this can be used to make these dopamine neurons. So the more recent way to make these stem cells are from people, donating healthy individuals. And this is the Japan trial is using this type of stem cell. So this is called an induced pluripotent stem cell. And this doesn't come from an embryo. They've been around for less years than the embryonic stem cells, but I think everything will move towards this type of stem cell because we can get it from a consenting adult. So there's two places where they come from. But in all the trials, they're only using one stem cell line for all of the people with Parkinson's. So there's not multiple stem cell lines for each person. And in the three trials I mentioned, there's no personalized medicine, meaning you don't make your own stem cell and then they transplant it back to you. So in each of those three trials, there's one stem cell line for the entire cohort of people. So therefore, they do need immunosuppression.
And who is the ideal candidate for this type of treatment?
Yeah, so that's a very good question. So this had to be carefully considered because they want success in the early trials, and then the criteria for the ideal candidate will broaden. So this is a really good question. So at the moment, I can say that people on these trials are in the mid stages of Parkinson's. So they have typical sporadic Parkinson's. I think there is at the moment an age limit, it might be 70 or 75, but that will surely increase. But not late stage Parkinson's at the moment because they
just explain mid stage and late stage.
Yeah. So
mid stage is Hone and Yard 2 to 3, is it?
Yeah, 3.
Let me rephrase. Would Dave and I be an ideal candidate for this sort of treatment?
You may be, actually. So you've not had DBS, right? Neither of you?
No.
I am due to have DBS. Will that rule me out?
At the moment, yes. Yeah,
right.
At the moment. But when people have asked me, should I hold off my DBS? I always say absolutely not. DBS is a tried and tested therapy, and when it works, it is absolutely transformational. We don't know what direction this stem cell therapy is going to go. We don't know when it might be available on the NHS. And DBS is tried and tested, and it works quickly. Exclusion of the DBS situation will not be in place forever. Because someone has had DBS, may not exclude them from a stem cell therapy in the future. At the moment, it does for these 3 trials. I know for sure that all 3 of them, to be on this trial, you cannot have had DBS. But it doesn't mean that's going to be like that in the future. So the other ideal candidates are people with autosomal recessive Parkinson's. So PINK1, Parkin, DJ1.
Genetic types of Parkinson's,
Genetic form, yeah.
of which there's about 15% of the Parkinson's population. Something
I
of
don't
that
think it's
magnitude.
that much in this country. I was interested to hear that in the Pacific Islands, PINK1 is very prevalent. So these type of Parkinson's, it absolutely looks like Parkinson's, and levodopa is a brilliant therapy for them. But they often don't have a lot of the other symptoms of Parkinson's. They don't usually go on to have cognition problems. They don't have the constipation. They don't have all these other complicated Parkinson's symptoms. So they're what we call, they have a pure nigropathy. So the substantia nigra neurons are being lost. So the dopamine replacement therapy works, the levodopa, but they don't have all these other complicated issues. So what we make in the lab are these dopamine producing neurons. So we argued that cell replacement therapy would be ideal for these individuals because the part that they're missing is exactly what we're making in the lab, right? And they're usually young onset, so they can deal with the surgery much better. Recovery is much faster. Percentage of this population is quite small, especially in the UK. But what I was saying is that they may do exceptionally well with this stem cell therapy.
I have to say, this is the most exciting part of Parkinson's research I've ever heard. It's incredible. The fact that you could potentially reverse Parkinson's is amazing. It must be very exciting for you to be involved in it.
It is. And you may not know the history of cell therapy for Parkinson's, but it goes back to the 1980s. And they were replacing cells then in Lund, in Sweden, and also in the US, but they were using fetal material. So they were using precursors of the substantia nigra, but from donated fetuses, because they didn't have stem cells in the 80s and 90s. And they had some remarkable success in some individuals where they literally, their Parkinson's symptoms were reversed, their levodopa went down to zero, they were playing tennis, they were doing things that they hadn't done for decades. It didn't help some individuals, and then some individuals, the therapy actually made them worse. Although they had some success with some individuals, it was stopped very abruptly because it was turning into a bit of a disaster. So there was a 15-year moratorium on this cell replacement therapy. And also they were using donated fetuses, which is very ethically problematic, logistically and ethically problematic. So now that fetal tissue is not being used, that we can make these cells in the lab, a lot of the ethical issues are removed, but also a lot of the logistical issues are removed. As I mentioned, we can freeze them at this transplantation ready stage. So you can make
like the cockroaches.
Pardon me?
Like the cockroaches.
Yeah, exactly. That's why I said we'll come back to the freezing. So the freezing, we have a paper just on freezing. We work with a company in Cambridge just how the best way to freeze these progenitors, because you need lots of them and you want to have large batches. You want to have hundreds of vials. You don't want to be waiting on donations of 1 or 2 fetuses. You don't know when you're going to get them. You want to freeze them transplantation ready. You want to have what's called a live cell product, and you want to have a lot of quality control over these hundreds of vials. So freezing is a big deal, right? But it's really complicated because it's a therapy. It's a live cell therapy, which is unlike anything biotech has looked at before. They're used to drugs, antibodies, mechanical stimulation, so all these things big pharma is used to. But a live cell therapy that needs to then develop inside the brain, you're like, oh my gosh, it's so complicated. How do you wrap your head around that? And a lot of scientists working on this, they don't come from a background of developmental biology. So a lot of the complications are difficult for them to wrap their head around, right? They're used to designing drugs, right? And they can do, but this is a living therapy, which is remarkable, right? And you're also asking it to replay embryonic development. So this type of development would have happened probably in the 2nd or 3rd month of gestation in the womb. We're asking that to replay itself in the brain of someone with Parkinson's.
It's like you're planting a seed, literally, right? Into the brain.
That is a good analogy, actually. That is a good analogy. Can I just play on that analogy? Because one of the things that Roger Barker says, so Roger Barker is a neurologist in Cambridge who is a major part of this trial, is that it is like planting a seed, but the soil, the part of the brain that needs to accept that seed, needs to be fertile enough for the seed to develop. And what they learned from some of the fetal trials in the 80s and 90s, if you transplanted the cells too late, they wouldn't take. Which is why I said earlier, mid-stage Parkinson's, not too advanced, because the soil where you plant the seed or those cells needs to be receiving of these cells to develop and make connections and make dopamine. So the fertile nature of the receiving brain needs to be appropriate as well. So it's a good analogy.
Alpha-synuclein is the thing that kills these brain cells, isn't it?
In
neurons.
in a lot of sporadic Parkinson's. So it isn't what happens in PINK1 and DJ1 in Parkin. So alpha-synuclein is not sort of moving in the brain of PINK1 and Parkin patients, which is why we also say stem cell therapy would be good for them. Because one thing that was discovered from the trials of fetal tissue is that the transplanted cells got alpha-synuclein pathology or Lewy body pathology. So although the cells were transplanted were new, they eventually also got Parkinson's.
Oh dear.
So it took a long time. It took over 10 years for it to get Parkinson's. And the people that did well, it didn't affect their recovery from symptoms until 15 years out. But the cells transplanted are not immune to getting Parkinson's themselves. So again, this is why I mentioned early on, this is not a cure. Parkinson's is still going on, but it does replace a really critical part of the brain that can now make dopamine again in a natural way that doesn't require the drugs. So it's part of the answer.
But there are plenty of conditions that haven't been cured, but in practice, people live very well with the condition with some of these revolutionary treatments, right? Like asthma, heart disease, HIV, and so on.
Even cancer. So, cancer, I've not heard that cancer has been cured, but actually it has been cured many times over. Many people are surviving cancer now that would have died 30 years ago.
Parkinson's is so complicated, isn't it? There's not one size fits all for a cure. It seems like everyone's going to need tailored medicine. That's going to be difficult, isn't it?
I agree. So I think cell therapy is part of the answer, especially in the next sort of several decades of dealing with Parkinson's. But in the long run, I think Parkinson's will be dealt with and quashed by early detection and then preventing with the right drugs. But for the next few decades, I think a cell replacement therapy and drugs that stop the progression of Parkinson's. So Jun Takahashi, the scientist running the Kyoto trial, really pushes this idea that the real answer to holistically treating Parkinson's, in his view, is a cell replacement therapy plus a drug that stops the movement of the pathology or the alpha-synuclein. So you mentioned alpha-synuclein already, and I mentioned that the graft isn't immune to alpha-synuclein, so alpha-synuclein or Lewy bodies can move into the transplanted cells. But if you have a drug that stops the movement of alpha-synuclein, which is just a drug that could be useful for anyone with Parkinson's, but if you combine that with a cell replacement therapy, you stop the progression of Parkinson's and you have new cells. This combination will give you what looks like, we're starting to approach what looks like a cure.
How far away do you think we are from that?
So those two things haven't quite happened yet. So the cell replacement therapy is in clinical trials, as I mentioned. There's 3 major ones. There's lots of other smaller trials going on. So cell replacement therapy isn't in place now, but it's looking much more promising than it was 10 years ago when we were just in rats and monkeys. So this is happening in people. And there's lots of other efforts to find drugs that slow and stop the progression of the pathology. So these are what we call disease-modifying drugs. It stops the mechanism of Parkinson's, not addressing the symptoms, stopping the mechanism. So a number of these drugs are also in clinical trials. There isn't one that we can point at and say, this is the winner. Well, it'll happen, but when that happens, we don't know. And maybe there are going to be a couple different winners. But these will be small molecules, hopefully taken orally. So combining that winner with a cell replacement therapy in the same people will be a much more holistic view of how Parkinson's will be dealt with, in my opinion, and many other people's opinions as well.
So people listening to this, I think, will be quite heartened and quite hopeful about this stuff. But we get a lot of people that are newly diagnosed that are fearful of starting levodopa. We've got a lot of people that kind of mid to late stage, like me, that are considering DBS. Your message to them is, this is promising. We've gone from animals to humans. We're at stage 3 trials. It's happening, positive results, but don't wait, right? If there's a treatment that's offered to you today that can change your life today, and this is the lesson I've learned, don't wait until the what's next, right? Because there's no guarantee with these things. You're nodding away, right?
Yeah, absolutely. Yeah, I'm nodding. I'm not saying. I know it's a podcast. Yeah. Don't wait. No. And the other big message from your podcast and Movers and Shakers and from people like Joy Milne is take charge. There's so many things that you can do to slow the progression, to make life much better. You need to take charge, right? It's great that you get inspired from the work that we're doing, but Parkinson's, there's so much information out there. I think your podcast is medicine in itself. You need to take charge of your own Parkinson's. Exercise. We host an Edinburgh Parkinson's lecture once a year, and we've had one on exercise, on diet, so lifestyle ones. We have science ones as well, but there's so much that can be done personally. Assemble your team, do your things, and you can slow Parkinson's, I think, by some of your activities, right?
So I was on a patient panel for Blue Rock, the subsidiary of the biopharmaceutical company that's doing this clinical trial. And one of the things we were talking about is myths and people's perceptions and their barriers to adopt a new procedure like this. And we were using DBS as an example. Do you fear that we might be in that position with stem cell therapy, and that it'll be great, but because it's new and it's fairly invasive, that people will be reluctant to take it up?
Yeah, there's a couple of issues that you're pointing to. So the word stem cells is unfortunately also associated with lots of different clinics, sometimes in the Bahamas or Mexico.
Anecdote here, if I may. I was on my Instagram feed this morning and I got one of these clinics adverts popping up saying stem cells for Parkinson's. Should I ignore that stuff?
Absolutely. Absolutely ignore that stuff. So they're taking some blood stem cells or stem cells from your fat, and then they're reinfusing it into your veins. It's absolute nonsense. It's absolute, it's fraud almost, right? Where they're trying to, but they're using the word stem cell, which they kind of are, but they're blood stem cells. They cannot make dopamine producing neurons. So this, unfortunately, when you hear, stem cell therapy from Blue Rock or from Lund, this also comes into the picture, which becomes very confusing, right? Because you have all these charlatans trying to provide a service for a hefty fee that has no efficacy. It just doesn't work, right? So whether this knowledge or fear of the poor stem cell therapies causes any reluctance of uptake of what we consider, an efficacious stem cell therapy, I don't know what will happen. But there's a neurosurgeon I know in Toronto. So his view was that the neurosurgeon should be able to offer in the future a range of things depending on what the person with Parkinson's needs. So deep brain stimulation, of course, is standard and it can really work. Cell replacement therapy, he thinks should also be on the table, and then focused ultrasound, which is also what the neurosurgeons do. So these three sort of functional surgeries, they're called, should be on the offering for a neurosurgeon, depending on what would be most suitable for the person sitting in front of them, right? This is how he views the future of neurosurgery in Parkinson's. But cell replacement therapy will have a place in it, hopefully.
You mentioned Joy earlier, Joy Mill, who we had on the podcast, the woman who could smell Parkinson's. We heard the story from her about this conference that she attended, and she stood up and asked the panel, including yourself, a question about why aren't we looking into the smell of Parkinson's? Can we get your side of that? What did you think when you heard that question?
Yeah. So it was actually in the building I'm in now, sort of half-day seminars of Parkinson's UK organized. And yeah, she asked that question after I talked about stem cells and, making neurons in the lab. And then this question out of the blue, just I was absolutely confused. I had no idea what she was talking about. And it didn't make any sense at all. I was like, what is she talking about? And I think I said, do you mean they lose their sense of smell? Because I said, yeah, that's known. People with Parkinson's lose their sense of smell. She said, no. Do they smell different? It was very bizarre. Yeah, it was only many months later that someone in Edinburgh mentioned, that some cancers have a unique odor and you would never expect that. And I said, yeah, you're right. I wouldn't expect a cancer to have a unique odor. So she encouraged me to find her, because she wasn't from Edinburgh, I knew, because I knew a lot of the Edinburgh Parkinson's UK people. I eventually did find her. This is now almost 10 years ago, and we tested her, and she was incredibly accurate. I think there may be a diagnostic test on the way through Manchester. But I think two things that she really hit home is that it is possible to detect Parkinson's early. As I mentioned, the really long-term vision of Parkinson's, ending Parkinson's, is to detect it early and prevent it. So you don't need any DBS or cell therapy. And the other thing that she really emphasized is that you can take charge of your own Parkinson's, right? She worked with Alison Williams in Edinburgh, and they were recording the smell level. She has these levels. And Alison was able to reduce her smell and her symptoms using the things that she did, Tai Chi, and she just took charge of her own Parkinson's. Working with Joy, you could see that she improved her situation, right? So these are two other major things that Joy sort of brought to the community, in my opinion, right? She's just an amazing, amazing woman. Above and beyond, having this smell of Parkinson, she's really opened eyes, I think, to a lot of other things.
Excellent. Yeah, she's an amazing woman. It's an amazing story. I feel like the schoolboy cockroach instinct in you was triggered when you heard that story and you sought her out. Wonderful example of pure scientific interest, I think.
Curiosity, yeah. I didn't seek her out right away. I was very skeptical, but I'm very glad I did. I think it was 8 months later I found her. But you're absolutely right. It was a curiosity driven. I think, a lot of people would never have followed that up. She tells me that she picked me, her and her husband Les picked me for some reason. And then she decided to come to Edinburgh, not knowing that I would be crazy enough to follow up on it. But yeah, it is serendipity, it is curiosity. Yeah, and it's a really great story. And she's just been a great advocate for Parkinson's as well.
You won the Tom Isaacs Award for that as well, didn't you? Which is great.
I did, 2019, yeah, engaging with people with Parkinson's, because it involved working with a lot of people with Parkinson's in Edinburgh as well, right? Because we needed to test her ability somehow. And you're absolutely right, Dave. Yeah. So Tom Isaacs Award 2019 was a result of working with this team, working with Perdita Barron in Manchester. It just blew up. It was a really, really amazing story.
And not to get political here, but a lot of your colleagues are from around the world. What impact has the New World, Brexit and so on had on your work?
Yeah, I think the Parkinson's research, it hasn't majorly affected. There's a lot of communication. We are having issues, of course, with getting research students, so we don't get the number of European research students coming in from France and Spain and Germany, Italy, etc. I think the number of quality students in our population is not as diverse as it used to be. But the research, I think, is still going ahead full steam. So Brexit, all the issues in America, this is not going to stop the collaboration and the working together. It's such a really good community. So one of the other issues from the fetal trials back in the 80s and early 90s is that there wasn't as much communication and collaboration, and people were going on their own, sort of trying to do stuff on their own without communicating. But there's a lot of communication for the cell therapy world for Parkinson's, which is really positive, and it makes me very hopeful. And there's also a lot of money now involved. So when this was going on for the last 30 years, there was very little interest from pharma. And now there's lots. So big companies are involved. There's lots of funding, which also means there's a good chance of success.
It gives us Parkies a lot of hope when you say that, because people used to protect the work like an exam. You'd put their arm over and protect the work. I saw a picture of you with Shinya Yamanaka, the guy who won the Nobel Prize.
Yeah. So Shinya Yamanaka, I actually knew him before he discovered the stem cell technology that he won the Nobel Prize for. So I actually met him in my first month I was at Edinburgh. So 2003, Shinya and I went to the pub and we were talking about different stem cell work that I was doing in Toronto that he was doing in Kyoto. So we were working on stem cells well before he was famous, and he was very good friends with my boss in Edinburgh. So I knew Shinya in the early days. He and his team helped me make the first iPS cells in Scotland. And I've been to Kyoto twice to speak at his institute. I brought him some whiskey from Edinburgh. He is a great guy, and he is eager for his stem cell discovery to help towards a cure for Parkinson's. So the new director of his institute is Jun Takahashi. So I mentioned him before. He's running the Kyoto trial. So he is one of Shinya's, top scientists, and he's now the director of the Kyoto Institute and is a Parkinson's neurosurgeon. So Kyoto, Shinya Yamanaka, all those, that grouping in Japan is really working hard to bring this therapy for Parkinson's.
Talking of Japan, I heard you mention something on a video once about prevalence of Parkinson's. In every single country around the world, men outnumber women with Parkinson's around 60 to 40. But in Japan, it's the opposite way round. Do we know why yet?
I don't know why, but it is true. I don't know if it's 60-40 the other way around, but definitely women in Japan get diagnosed with Parkinson's more frequently than men. So it might be something with their genetics in the Japanese ancestry where it makes it slightly more prevalent in women. I don't know. But I'm glad you brought that up, because gender is really important for Parkinson's. And there's lots of different issues with men with Parkinson's versus women with Parkinson's. And it's really good that all the trials now are trying to be as gender balanced as possible. a lot of the animal work that I was describing, so a lot of the mouse work and the rat work used to be all done in male mice. But that's all changed now, thankfully, at least in the UK. In the UK, you can't get funding to do any sort of animal study, not just for Parkinson's, for anything, without including both male and female animals. So it's super important. But the original question, why Japan has more preponderance of women with Parkinson's, I don't think anyone knows. I don't think it's environmental. It's likely due to some background Japanese genetics.
Before we go, is there anything else that you want to mention in your area of work that we haven't come across? Or It feels like we've covered a lot already.
So I didn't speak much about the disease modeling, which may be a bit harder to...
Please do.
It's using the same cells, of course. So we take them from the stem cells, we make them into progenitors, and these are the cells that are frozen and given to the neurosurgeons. But if you keep them going in the lab, you just keep them maturing in the lab, in a dish, they will make neurons. They will make quite nice neurons that will make dopamine, and they will start firing electrical activity. So you can get activity in a dish. If you mature the cells too long, such as neurons, they don't transplant well. So it's a practical reason why the transplantation is done as immature neurons. If you make proper neurons in the lab, they don't transplant well. They've tried it in lots of animals, they just don't survive. So you have to transplant the progenitors, and the maturation has to happen in the brain. But in the lab, we can try to model Parkinson's in a dish with neurons. And we do give it so Lewy body-like structures, and then we look at drugs to see if we can reduce the Lewy body-like structures. So that's just the efforts of many labs, including my own, to find these drugs that will slow and stop the progression of Parkinson's. So the second half of the solution, can we find drugs to do that? So this is where we spend actually most of our efforts. So we don't work on cell therapy a lot in my labs or other labs that are doing that. But my lab in Edinburgh, we make neurons and we test drugs.
Fantastic. Really great. Really great.
For a couple of immature neurons like me and Dave, sounds quite hopeful. So thanks for breaking that down. Very last question before we go. I think you said you heard the last podcast where we had a young lady from the Pacific Islands give a talk at a conference in London, a young lady with Parkinson's, and she closed her talk by asking this question of researchers. And if I can ask you the same question, if you did find the cure for Parkinson's today, who would be the first person you'd tell? Who has left an imprint in your mind that the moment you discovered the cure, that you would leave the room instantly and go straight to them and tell them about this life-changing outcome? Who do you want to see have life brought back into their soul? Keep them close to you and let them be a reminder of why you are working so hard to find the cure. What about you, Tilo? Who comes to mind, or what comes to mind when you go to work every day and you're doing this wonderful research?
And I mentioned my friend John McPhee in Perth.
Please
Perth.
do,
Yeah,
yes.
John is a great guy, young onset Parkinson's, and we ran a park run together for Jessica Ennis Park Run Heroes. I think John McPhee, I would love to tell him such news. He's just an amazing guy. And we did a fringe show together. If I'm going to pick one person, it would have to be John McPhee. I'll let him know that I told him that as well. Yeah, he is a great guy. Yeah, absolutely. Yeah.
I know John very well, actually. I walked coast to coast and he joined me for half of it. So a great man, yeah.
Yeah. Oh, good.
He also walked the length of Britain in a long straight line, didn't he?
He did.
So incredible guy, yeah. Top man, yeah. In fact, I'll ring him after this podcast.
Tell him I mentioned him, yeah.
Great. Top man, Tilo. Thanks so much.
You've been very generous with your time and very informative discussion. Thank you very much, Tilo.
Thank you. Keep up the great work. You guys are amazing. Thank you.
That was a fascinating interview. From freezing cockroaches in his mother's fridge to head of regenerative medicine at Edinburgh University. It's been a hell of a journey for Tilo, hasn't it?
Well, it's probably not that much of a leap, actually. It's that inquisitive scientific mind, right? It's great that we've got people like that in our corner, right? Trying to find a breakthrough. And if I had my time again, maybe I'd go into science. It never fascinated me before, but hearing this sort of stuff, it's mind-boggling, isn't it?
He's an incredible guy. It's amazing the technology's been around since the 80s as well. They tried it at the Sweden project. I didn't really know much about that.
It's typical of all these things, right? It's like levodopa, introduction of DBS. They have some teething problems early on. They go into trials with animals, with mice and so on, and then they start their clinical trials. They learn. Sometimes they fail, but they move on. That's the nature of science. But it's reassuring in a way that they've been researching this for decades now. But I think the thing that stood out for me is it's still some time away, right, before it's a practical solution for us humans with the condition.
Quite interesting, he said that don't put other treatments on hold because of this, because it's going to be a while. He mentioned 10 years. It could be more than that.
And I'm the prime example, right?
Yeah.
I mean, I've got DBS literally on my plate now. I'm not going to turn it down because I can't afford to wait that long, you know. So if we are talking about years, potentially a decade or more, then I'd rather go with the devil I know. Is that the right expression?
Yeah. Better the devil you know.
Better than the devil you know.
It's a Kylie Minogue song as well.
Is it?
For our Australian listeners.
Right. The other thing I'd say is the people that volunteer for this stuff, my word, right? How brave are they?
Brave people. Yeah.
And the people that are potentially getting sham surgeries as well. You need people that are going to have potentially be part of the control group where they have invasive brain surgery and have nothing fed into their brain.
Yeah.
They're just doing it purely for the pursuit of science. Is that the expression? But, you know, it takes some real brave volunteers to have things drilled into their brain, knowing that they might not be getting the treatment itself, right? I mean, I don't think I could do that. Could you?
No, I think they were saying they're looking for potential candidates as well. Better if you've had Parkinson's for fewer years.
Right.
Incredible guy. Great to hear them collaborating between the centres as well.
Yes, and we should also give a shout out to Cure Parkinson's as well, because they're funding a lot of this stuff. And one thing I've noticed, obviously both Parkinson's UK and Cure Parkinson's do some great work in this area, but Cure Parkinson's in particular are very good at bringing their international colleagues together and funding internationally, and also just comparing notes. We're all in this together, right? A Scandinavian version of Parkinson's doesn't look much different to a Yorkshire version, right? Or an American version or an African version, whatever it is. I see a lot more pooling of resources and knowledge. And I was interested by Tilo's comment that Brexit doesn't really stop scientists, right? Which is also quite heartening in this world where countries are going their own way, unfortunately. But, you know, we're trying to keep politics out of this, but I'm reassured in the persona of scientists. They just want the right thing for the patient, right?
Hopefully there's no tariffs on scientific research.
Hopefully not. Well, and hopefully not drugs as well, which you could well imagine happening.
I'll tell you the other fascinating thing was the story behind Joy Milne and smelling Parkinson's.
Yes.
That was a great story, wasn't it?
It was.
It shows you the inquisitive brain, doesn't it?
It does, and we heard it from Joy's side in a few episodes back, the woman who can smell Parkinson's. Now we heard it from the researcher. Tilo was the guy who was fielding the question which Joy asked, and it was, again, his inquisitive nature that prompted him to follow up, and we're literally on the verge of a test for Parkinson's off the back of that one chance encounter. Two amazing people on the opposite end of the spectrum, the Parkinson's spectrum, have come together, and through that story, something's come out of it. It does go to show that you have to involve patients in this. You can't do these things in isolation. I was doing a talk to a pharma company last year in front of their entire neuro division. There's, I don't know, about 100 people there, and I was just asked to do my story and my journey with Parkinson's, and I did my bit for 10 minutes and I invited questions, and I think everybody was quite moved. I was getting quite choked up myself, and somebody put their hand up and said, I don't have a question, but just an observation. I've been working in this field for 10 years, and it's the first time I had a chance to meet somebody with Parkinson's. Isn't that quite remarkable?
That's incredible, yeah.
There are people that, I don't knock them for what they're doing, but, you know, the white coats that's sitting in their lab with their microscopes and cells or whatever it is, just go out and meet some people with Parkinson's. Just hear it and see it firsthand, because there's nothing like it. And when the two come together, literally magic can happen. And you've heard that from Tilo.
Yeah. Patient participation is huge, isn't it? You know, more you can tell your story, do things like that, the better it's going to be for us all.
And we need more people from different walks of life, if I can put it like that, different shapes and sizes, different colours, different races, different genders, all of it to come forward. And I really believe that we can find a breakthrough if we all come together. If we can view this like a COVID thing. We had hundreds of thousands of people coming forward to take part in clinical trials. It was unprecedented. We got to a cure, a vaccine in that case, in less than a year. In less than a year. Imagine what we can do if... I get quite emotional talking about this. Imagine what we can do if we had that kind of... What's the right word I'm looking for here for, Dave?
Revolution?
Yeah, I guess it is
Movement.
a revolution. A movement for a movement disorder. And, people have got to get off their backsides, if you don't mind me saying so. Get involved in research. We'll leave the links in the show notes. Reach out. Don't be afraid. Also, researchers, don't be afraid of reaching out yourself to patients as well, because you ask somebody, do you want to take part? I've never heard of anybody say no, at least initially. I've never heard of people that are reluctant to take part in research. I think it's a bit of a myth that one of the barriers, or one of the main barriers, I should say, is people's reluctance. Yes, there are going to be concerns, but you tap somebody on the shoulder, invariably they're willing to help the cause. And just as a side note, I got invited to take part in a piece of research, and the lead researcher sent me an email, said, I'd like to invite you to this research program. I hope you don't mind me asking you, because quite frankly, we're looking for people that are like you. And I don't think she meant young and handsome.
Definitely didn't mean that.
I think what she meant was people, what she did mean was people from different ethnicities.
Yeah.
And I said to her, yes. And I absolutely don't mind you asking. I wish more people would ask me. And I wish more people would ask people of all different walks of life, not just people that are normally prone to take part in research. Normally it's the
White middle-class men.
Well-educated, that can have the motivation and know how to take part in research. And the time, yeah. If you've got a full-time job, taking part in a research study is near on impossible, especially if it's a clinical trial that involves drugs and you've got to go to assessment centres and stuff. It's impossible. So I think there's a learning there as well on research side to make this a little bit more easier, make it more accessible, reduce the admin associated with research, because it's a burden for people that have got cognitive challenges.
You don't want to fill in loads of forms, do you?
Not filling in loads of forms.
Signing papers online and stuff. Hard, really hard.
It is. The simple things are hard for people with Parkinson's, but I do believe when we can come together, we can find the answer, or at least part of the answer.
People like Tilo as well. Right in our corner.
Exactly. Sorry, I went off on one there.
It's fine. Let's have a bit of this.
People with Parkinson's do amazing things.
Fellow Parky, Ozzie Osbourne, whose band Black Sabbath will play one final gig on July the 5th at Villa Park in Birmingham. The event, dubbed Back to the Beginning, will also feature Guns N' Roses, Metallica and Slayer. Ozzie says, I'm planning not to do a full set with Black Sabbath, but I'm going to do little bits and pieces with them, whatever I can manage on the day. So that's good.
I think that's a good motto for Parkinson's, whatever I can manage on the day, right?
Yeah. Perfect.
Well done.
Ozzie, the Prince of Darkness, go on, lad.
People with Parkinson's do amazing things.
Bit contrasting this. A big shout out to Peter Cook, who's taken up the ukulele to ease his Parkinson's symptoms. He wants to form a ukulele group in the UK. If you fancy strumming his banjo with him, Facebook details are below on the show notes.
You know what I think about ukulele? What comes to mind?
George Formby.
We're
cleaning windows.
do that again. Do the whole thing.
No,
Go on.
No. You're not dragging me into that trap.
People with Parkinson's do amazing things.
The all women walking football
Well, some of them are working as well, right?
Walking football team. Parkinson's Pioneers have been awarded a Walking Football Association Team of the Year award. Team founder Anne-Marie Booth has been praised for her inclusivity of the team. It doesn't matter if you've never played football before. We'll welcome you with open arms, says Annie.
Yay, well done.
People with Parkinson's do amazing things.
Have you ever wondered what it'd be like living on a paradise remote island with Parkinson's? Say aloha to the wonderful Lisa Harris Murphy, known as Island Living Lisa on Insta. She shows you how to exercise and stay positive whilst living on the Hawaiian island of Kauai.
Lovely. I think she's the one that had focus ultrasound as well.
Right.
So it'll be interesting to see how that turned out for her.
It's incredible. You see her walking along paradise beaches with Parkinson's and under palm trees. Amazing. It's really worth watching. Have a little tune into it.
Excellent. Is that it? Have we got another one?
No, that's it now. That's it. I'm off.
You're off in what respect?
I'm going off.
You're going off. Fair enough. Shall we close the show then?
I think so. What are we going to say at the end?
I don't know.
If you want to get in touch, 2 Parks in a Pod.
2parkinsonapod.com. hello at 2parkinsonapod.com for emails,
We love your voice messages as well.
Yes, we've started to receive a few, and it's really nice to hear a voice. And don't forget, we've got 40 episodes before this that are well worth a listen for some of our newer listeners. And any suggestions for people who do amazing things, topics or guests, feel free to drop us a line.
Great. See you later. Bye.
See you later. Bye.